Good morning, all. I hope you have been able to implement the recursion discussions and recursive programs which we discussed yesterday. So, just to recap, we have talked of recursion yesterday, and for recursion, I have given you some basic problems to be solved by using recursion. Like I have told you to print n minus 1 up to 1 function series, and other side I said you to print 1, 2, 3, 4 up to n. So I have asked you to try to implement these programs, and hopefully all of you have been able to do. Just to give you an idea what could be basic philosophical differences between the two, let me just share with you some basic difference between these two. So I'm sure both of you have been, all of you have been able to implement both. How they will be, how implementation will differ between these two. Of course, you could have done in different manners, but if I say that, assume that you always have your condition of stopping criteria, you always say if n is greater than 1, then it is recursive. Else, you always simply say you have to print f1. Effectively, 1 or n, whatever you say. But if you used this logic for both programs, then how the two will differ? Both programs above would have been same logic based. Then how that implementation will differ? So I'll say effectively implementation will differ in the sense of the order of recursive call versus the printf statement. That's it. If you are able to just think in those lines and your answer comes just with these precise words, it means you are understanding the programming well and doing well. Of course, if you understood this answer, still you can easily appreciate yourself that yes, you are able to differentiate between the two workings. But in interviews, etc., your precise answer, crisp answer with precise words will be much more helpful than explaining it in 5 lines. For example, if I say I have to print n down to 1, if you were supposed to implement this as a display function, let's say you made some display function where you wanted to display it n minus 1 and so and so. Then, of course, this could be a void function because I have nothing to return. Now, what basic logic of programming says that you should be able to differentiate which part is to be done by recursively and which part not to be recursively. Of course, you could say if n is less than equal to 1 or if n is equal to 1, you will be simply printing. So I'll have a printf, else I will have a recursive call. Or you could also say if n greater than 1, then I will have some recursive call, etc. One and the same thing, either way you write. But now the basic philosophy behind understanding recursion is you should be able to divide your solution. I say you should be able to divide your or plan your solution in a way. For recursion, the thumb rule is plan the solution in a way that problem gets reduced or divided to a sub-problem which must be solved recursively. If you are able to plan like this, effectively, your recursion will be very easy to solve. For example, this itself. I say, can I divide the solution in a way or plan the solution in a way that some sub problem gets solved recursively and rest steps are needed. And there will be some other steps which are obviously non-recursive. For example, here I say display n is equivalent to saying n to be displayed and this series to be displayed. I said display n is equivalent to step 1 and step 2. Step 2 is again displaying series n minus 1 down to 1. Earlier series being displayed was n down to 1. Now it is n down to n minus 1 down to 1. And you could say this is the first step. So I could simply say printf %d n followed by a display call and display n minus 1. This is equivalent to saying display n minus 1 down to 1. Same sub problem getting solved automatically. On the other hand, if I was making call for display n as a function to display 1 to n, now my logic will be slightly different. I will say I will consider my function to have two steps. Step 1 to display 1 to n minus 1 and step 2 to display n. Now, having said that, step 1 is again a recursive call to the same thing, but it must be repeated or completed first and then n should be displayed. So if I say, let's say this was display 2 function, this was a display 1 function, my display 1 function will be recursively called after printf, but here first I will have a display 2 function, of course with if n greater than 1, then only this will be done. Display 2 n minus 1. This is equivalent to displaying 1 onwards up to n minus 1. And then I will have a printf call for displaying %d and n. Of course, I can give a blank in between so that the values appear with some gap in between. So I can have a blank here also. This symbol B cutting arrow, this is used to display blank. So while typing, you can keep a blank in between. Here also you have, it is equivalent to saying I wrote %d and then left some space and this. So you could say this is equivalent to saying writing like this. And now you can say this is a step 1, this is a step 2. So the ordering of recursive call, in this case, recursion first and then display. Earlier it was recursion later and printf later, printf first. So this way can be, otherwise rest logic is same. Of course, others or some of you might have done 1 to n display in a different manner also. You might have taking condition, say n is going to be with some limit and then you are going to check that limit, but we have never said that there is a limit being discussed. So you could say, yeah, I will send n. So I will say if n is equal to 1, I will have a printf. Else you could say I will have a printf of n being passed and then calling display of n plus 1 onwards. But if you call display n plus 1, where to stop? So then you need to have probably an extra parameter, otherwise you will not be able to reach up to the last value. So if you say that I have some value to be gone up to limit, then n initially to be considered and all that logic. So that probably doesn't become as simple or as readable as we have just discussed. So normally reducing the size and going towards boundary one was the simplest logic because one is the stopping point. Other way could be increasing towards n, but then you have to store the final limit. That could be another way, but if you have to manage that. So I'm not going in further detail than that. Having said that, now we can resume further and go for more discussion. So recursion, I am sure now all of you are able to understand and do that. So using recursion, now we are going to do one of the best sorting algorithms, which we call as merge sort. It is, of course, one of the best and fast sorting algorithm. Of course, it may have its own disadvantages, but it's quite fast and very useful algorithm. Later, you will understand why it is fast and why it is so powerful or so useful. In algorithms design and analysis, you will study its complexity and efficiency and analysis issues. So then you will appreciate it more. But remember, this is one of the most useful and fast sorting algorithms. And we will define what a merge sort means. So merge sort I will define in effectively it has a 3 steps. What it says, number 1, divide your sub list or divide your list or divide the array or list, whatever you have, into 2 equal sized sublists. Then it says merge sort, I say sublist 1 and sublist 2. So I will say merge sort sublist 1 and merge sort sublist 2. Both lists are individual lists now and both will be merge sort. And then I say merge sublist 1 and sublist 2. That's it. Now you can easily see the merge sort definition using the same word merge sort again. It means recursion is visible. I can easily use recursion to implement this. Second thing is we are using the word merge. So how merging will be done, we will explain. Like in insertion sort, insertion word had a specific way of working. The merge sort has a word merge, which has a specific way of working, and that we will be understanding soon. Divide the list into 2 sublists. This divide doesn't mean physically separating the 2 lists. It will mean a logically division only. So it will be a simple logic. What does that mean? It means, let's assume I had a list. Say I had an ARR array with values 16, 3, 9, 11, 4, 7, 15, 8. Sorry. So this list has 0 to 7 total 8 elements. Step 1, divide. Divide logically means consider this list as 2 parts. This is your sublist 1 and this will become your sublist 2. Straight away, easy. So now I can easily consider sublist 1 and sublist 2 as 2 sublists. So effectively, my first step effectively means dividing it or finding the middle point. If it is an odd number of elements, one of the list will have normally 1 element extra, and that we usually take into the left sublist, that is sublist 1. If n is even, of course, both will have equal size. So simple. Then comes the second step, merge sort. Merge sort means this list is to be again sorted. Good part about the recursion is assume they get sorted easily. Assume that sublist 1 and sublist 2 are correctly sorted, guaranteedly correct, without any confusion. Assume this through recursion. Somehow it will happen. Assume. Once you assume, that indirectly means this list became something like 3, 9, 11, and 16 in the array. Add element 0 to 3. Earlier, this was the list. And this. And other side, let's assume some bigger values here, say 14, 7, 15, 8. So I will say this list becomes 7, 8, 14, 15. So this was 4 up to 7. So this got sorted without any difficulty through step 2. Now, then I have to merge these two lists. So I have to define what merge means. But if you see carefully, if I am able to define how merge will happen, my sorting is done. I have nothing else to do. How internally this list got sorted, I need not bother. How internally this sublist got arranged and sorted, I need not bother. Assume they got sorted. If you define merge step, your work will be over, implementation will be over. How does it merge? How do we merge? So merge is again in computer science engineering CSC, merge is a specific operation which is well defined in the computing domain. How it works? It is exactly simple and very close to one of the algorithms which we have already done. Let's write the values again. This was one sorted list. Another is this sorted list. Some indexes, starting indexes. I will say sorting means effectively comparing first element of the both lists. Let's assume this is I, this is J. So I will compare array I versus array J, and I will take extra temporary array a local array I will create, which will be obviously 0 to some bigger size, as big as which is needed. So upper limit of, let's say, 100, etc. you could declare, and something like this declare that will give you 0 to 99 and whatever needed. So at most 100 elements, lesser than that will be also okay. Now I will compare these two, and if the first value is lesser or equal, I will copy here. If it is copied, I will increment I. Now again, array I and array J compared. 7, 9, 7 copied into temporary array. Then this incremented, J coming here. 8 and 9 compared. 8 is a smaller, so 8 will be copied here, incremented. 9 smaller, so 9 will be copied. 11 versus 14, 11 copied, incremented. Both lists are not empty, still comparison is possible. 14 lesser, 14 copied, incremented. 50, I think we have 3, 7, 8, 9, 11, 14 copied. Then 15 compared versus 16, 15 copied. List over. Second list over. J goes out of limit. It will mean whatever remaining elements into first sublist are, they will be copied as it is. If there were more elements remaining, they will be copied. Similarly, if the second sublist had certain elements, first sublist got empty, then remaining elements of first sublist will be copied, second sublist will be copied as it is. If you remember, this logic we have already done. For another program, we have already done very similar logic. We have done the similar logic of polynomial addition based on exponent representation. There also we had same thing. We had two polynomials, we compared their exponent, and in that case, the greater exponent was copied, and accordingly we shifted the I and j. Of course, equality there had a special meaning. In this case, we didn't have equal value, but equality also we have to use carefully. So equal values will also have some solution that we will discuss after few minutes. But for the time being, I will say, yes, equal values will also be handled, and that equality condition we will check. For the time being, I have all unique values and I do logic based on this. Now, once we did this, I say my temp array got the sorted values. So merging step will mean now copy this back to temp, from temp to ARR, because my original array ARR was actually used to send the data, and that will be used for displaying or using that data. So you have to copy back from temp to ARR. That will be the final step, and this overall becomes the merge logic. So effectively, I have to implement the merge logic. Now, coming to the discussion related to equal values. Let's assume I had here 3, 9, 11, 16. Other list also I had, let's say 5, 9, 10, or I'll say further 9 also, 11, and or maybe 30, whatever. So I had these values to be merged. So this is my sublist 1, sublist 2. You took a temporary array, you compared and copied 3, j was here, this incremented, I came here, j copied, 5 copied, j increment. Now, you have 9 and 9. So, if equal value, what should we do? Of course, you could say doesn't make a difference, both are same values, but that could mean that you should copy both 9 here and then increment both I and j. I will say no, don't do that. Reason I will explain, but in such cases, I will copy this 9 here and increment I. So for equality, sublist 1 value will be copied in one step. Of course, all 9s will become adjacent to each other after overall merging, but this is important. Why? Now understand. I is here, j is here. Now this 9 will get copied here because 11 is bigger. So this j will shift now. After that, 11 versus 9 again comparison. This 9 will get copied here and process will continue like this. After that, no issues. So of course, all 9 came together, but in what order they came? First this 9, then this 9, then this 9. Indirectly, what it has happened is relative ordering of data with the same value should be maintained or should be preserved. What does that mean? In the original data, this 9 was coming before this 9 and this 9 was coming before this 9. I say same ordering should be preserved. If it happens so, it is called stable sort. And merge sort is by default a stable sort. So stability should not be disturbed. Why stability makes a difference? Of course, I would suggest you read book for more details. You must read the book. But quickly, I will answer your query in a few minutes. Why it is important is simple, that for you, probably 9 and 9 meant one and the same thing. But when I say that I had data 3, 9, 11, and so, and this side I had 5, 9, 9, and so, I say for you, this 9 and 9 means same data. But in real life, you will have big records where sorting will be done on one field. For example, say JEE rank preparation. Now, in JEE rank preparation, your rank JEE marks matter. So, in reality, each student record will exist, which will have roll number, name, address, etc., etc., physics marks, chemistry marks, math marks, total marks of JEE. So there is one student, there is another student. Both might have same total. Doesn't mean that records were same. Many students will have same marks, but there will be multiple students with the same marks. Then other fields will be different, and you have to take care that during sorting, whether you require stable sort or not. Because which out of these two should appear first? Of course, in JEE, your criteria could be based on PCM marks and etc., etc. So you might have said that this sub-sorting was done in a way that the candidates who scored equal marks, they were ordered already based on math marks. If math were equal, then they were ordered based on physics marks. If physics was also equal, they were further ordered based on chemistry, which will be obviously equal or whatever criteria. So if that relative ordering was already preserved, then while merging them, you should not disturb that. So this is what we mean. But yes, equal values, it doesn't mean that they are identical data. They are on only one field which is equal. Other fields might be different, and you have to take care that while sorting will happen, all other fields will also be needed in some situation. So you have to take care of that. So for equality, that's why we always said that if the left sublist element was less than or equal to, you will copy this element. Otherwise, you will copy from the other list. So this is what thumb rule we made. Now, knowing that, let's start doing programming. So I have to implement merge sort. So let's do coding now. Merge sort to be done. I can easily see for the time being, I don't require this to return something. So I could think to do it as a void merge sort simple. Let me just once again focus. If it changes, fine, good enough. Of course, you are all familiar. For any sorting, array will be always needed. So I will say int ARR array of 100 or whatever you have given. And for sorting, normally n is always needed. So you might choose int n. For initial start, even choose these parameters and start working. If any change in parameters will be needed, recursion might suggest automatically at a later stage. How to do? First thing, we have to always write stopping criteria. Without criteria of a stopping, I am never going to write the code. I must see this merge sort is not recursive every time. When is it not recursive? If I have a single element, nothing to be done, it's already sorted. So I could say if n equal to 1, return. That's it. Or otherwise, you could write if n greater than 1, only then you have some logic to do. And then you don't write this statement. You write this. If n is equal to 1, automatically you reach here. The code will be over. So it's your choice, whatever way you write. So I say I'm writing void merge sort. And here I have definitely an int array. And for the time being, I have assumed int n. If any change needed, we will see. And I said if n equal to 1 or if n greater than 1, I am doing some coding. Or if n equal to 1, write return, then you need not put this braces, etc. But if n is greater than 1, then recursion or whatever. I had effectively 3 steps. Step 1, divide the sublist into 2 sublists. Means logical division. Find the division point. How to find that? Try that. So I will say, now try to code that and write your code for step 1, step 2, and think of a step 3 by writing a separate function merge. I'm giving you a few minutes to try that. So you can pause your video here and try to do the coding of your own. Now, I will resume. Those who are trying, they can resume after they have tried. But just to continue my video, I'm assuming that you have tried and now you have your sample solution coding ready. Let's understand what we should have done by now. So step 1, divide the list. Effectively means I have to find a middle point. So I could say mid equal to nothing but n by 2. N effectively means my elements are 0 to n minus 1. Finding middle n by 2 effectively means that my list will be 0 to mid, and other list will be mid plus 1 to n minus 1. So if n was odd, left sublist gets 1 extra element, obviously, and right sublist will get 1 lesser element. So these 2 sublists are ready. Both are in the same ARR. Now I have to do step 2. What was step 2? Merge sort. Sublist 1 and sublist 2. Merge sort. Straight away programmable. Easy to write that it is nothing but a recursive call. Merge sort. Sublist 1. How to pass sublist 1 to my recursive function? Parameters have to be decided like this. ARR, and my sublist is 0 to mid. So how much size I should pass here? Approximately you could say, let's say mid plus 1. Mid plus 1 automatically means 0 to mid. Fine, I could be happy with this. Merge sort second sublist. How will you make this call? Recursive call, of course, ARR and size. How much is the size? Mid plus 1 to n minus 1. Maybe mid number of elements or mid minus 1 number of elements or mid plus 1 approximately. But if you pass here mid or mid minus 1 or mid plus 1, you could see the calls both have identical nature. this list will actually mean the elements being considered 0 to mid minus 1. If you call like this, although what we wanted was, we wanted the list to start mid plus 1 and go up to n minus 1. But that tells two different points to be told, starting index and ending index. So this call is incomplete. This call is incomplete because I'm not able to supply the different starting point. By default, starting point always assumed was a 0, and in a recursive call, starting point could be different than 0. That means supplying here n was not sufficient. So that straight away tells me that now my merge sort parameters will change. I will not just supply the array, but also supply the starting point and the ending point. That will help me in making the recursive calls easy. But that will mean from main, my call should be now made in a different way. From main, I will call merge sort with ARR1 or ARR2 or whatever we are passing, 0 n minus 1. Because there we have read from 0 as a starting point, n minus 1 as the ending point, but I must supply both of them as a call. So from the main, call will be like this. That automatically will send start and end as correct value. Now, here you will say if n greater than 1. Now, it's not n versus anymore, so it has to be start versus end. If there is some condition where you want recursion to happen, so you will find mid equal to what? You have to probably think start plus end by 2. Then you should be able to make a call to merge sort from where to where? Array. And merge sort 1, that is sublist 1, starts with start and ends at point mid. What about merge sort 2? Or merge sort for the second sublist? Second call will come with ARR. From mid plus 1 onwards, it should go, and the last element is at end. So now I am able to call recursively the list with correct indexes. Once these are working, they will return the sublist is sorted, and I should be merging them. So I will make a merge function and make all logic inside the merge. So what merge will require? Of course, array will be needed. Then it needs both sublists which are present inside the array, but where? So I know one sublist is present from start to mid, and second sublist is present from mid plus 1 to end. So I can pass one mid plus 1 also separately, but I say that is implied. So I can pass 3 parameters. This means your first sublist, and mid plus 1 to end will become second sublist. That is SL2. This was SL1. So I know my both sublists are present in ARR and merge call will be made. So what I'm left is only program to be written or function to be written for merge. How to write that? Now I will say it's simple. I have void merge, the corresponding parameters to be written, and I will require one temporary array. First of all, I will create that temporary array so that I'll get extra space to merge the two sublists. Then what I require, I will use of course, first sublist, let it start with I. So second sublist, let it start with J, and the merging data, which I will store in the temp array, let it start with index K. Similarly, polynomial addition also we did there. So what should be start value for I? Initial value for I. Yes, you are able to guess correctly. It will be start. What will be J? Starting index for the sublist 2. Yes, it is nothing but mid plus 1. What will be K? K I will use to store the elements in temporary array. So obviously K will always start with 0. So then I will need a loop. Of course, how many elements of sublist 1? I have sublist 1 here. I have sublist 2 here. Out of that, some elements of sublist 1 will be copied. Sometimes the sublist 2 will be copied. I don't know how many of sublist 1 will be copied, how many of them sublist 2 will be copied, when loop will be over. So for loop is not a good choice. Obviously, while a loop will be a good choice. As long as both sublists are non-empty, I will keep on comparing. Whenever one list will be empty, I will be effectively copying simply from the remaining elements, for the remaining elements. So what to do? Effectively, I have to compare if array I versus array J. And in one case, effectively, my temporary array K will get element from array I. In other case, I will have temp K equal to ARRJ. Whatever rest increment I, J, K or anything you want to write, you can think of that. As soon as one of the sublist is empty, and in this case, I can guaranteedly say one list will become empty, not both simultaneously, because I never take both elements collectively. I take one element at a time and copy into 10. So one of the sublist is guaranteed empty. So now what you have to do? Copy remaining elements of sublist 1 or sublist 2. As the case may be, into temp. All remaining elements. Again, this will require kind of a loop, kind of a while loop, and I can easily do that. In polynomial addition also have done. I'm not writing the code again. Once done, final step. What is remaining? Can you recall what is remaining? Temp array has got the data. This temp array will get destroyed. Local variable get destroyed as soon as function will be over. So we can't leave the data into this variable at all. Hence, we have to copy back this temp array into my original array. So copy back from temp to ARR. Now you have to be probably careful in this copying back. Be careful about the indexes. The indices which you will use for temp versus ARR. I'm just giving you one idea where you are likely to make a mistake. That will be more clear once I take an example. Just have a quick understanding in 2-3 minutes what really happened. I said I had taken data which was, let's say, initially I had 16, 3, 9, 11. This was my original total array. And then I had 14, 7, 15, and 8. This was my initial array. How really internally working happened? List was initially divided into two sublists. So this becomes a sublist 1. This became sublist 2. Recursive call further came to sublist 1. Sublist 2 will also be called, but later. First recursion came to sublist 1. This again saw size to be more than 1. List again divided into two sublists. Again, this became sublist 1. This became sublist 2. Recursive call again went to this. This was further divided into two sublists. One having one element, other having another element. Now, when this recursive call was called, it saw that it has only one element, so merge sort need not do anything. This also saw that this is one element, merge sort need not do anything. So the above recursive call made to this sublist now has completed merging of sublist 1, merge sort of sublist 1, merge sort of sublist 2 completed. This needs to be merged. So they will be now merged for the first time. So internally, they will get merged like this into temporary array, and then temporary array will be copied back, and this sublist is actually ready. Once this calls over, your recursion will resume at this sublist 2. So it will consider 9, 11 as sublist. Further, 9, 11 is more than one size. So divided, called for merge sort over list having 9, called for merge sort list having 11, and then merge both lists. Merge sort 9 will do nothing, automatically ready. 11 will also do nothing, and now merge logic will start. So merge logic will correct these values. Let's say they were in correct order or not, doesn't matter. Now they will become 9 and 11, and this 9 and 11 will be directly copied back, and it will become sublist 2, which is merged together. Now sublist 2 is ready with merge sort. Sublist 1 is ready with merge sort. Effectively, now previous recursive call with this sublist will restart. That means now I have one sublist 1, one sublist 2, and over this my merge sort was called, where merge sort needed to sort 3 to 11, or earlier rather that the data was 16 to 11. 16, 3, 9, 11 was being sorted. So individually this sublist merge sort, this merge sort, now they will be merged. Merging will mean this will become 3, 9, 11, 16. So this sublist 1 will get merge sort and ready like this. So this was the basis on which basis we said this works correctly. Similarly, other side data will also get sorted correctly 7, 8, 14, 15. And then they need to be merged. Now what I said is one important point of be careful about the indices. Just think, let's say how list 14, 7, 15, 8 was merge sort. This was a sublist 2, and this is being recursively solved. So obviously this will divide list into two parts. This will internally, let's assume, sort it as 714. and this will be sorted as 850. Now, they will be merged. Remember, 14 is at index 4, 8 is at index 7. So later they should come at index 4 to 7 only. See, this was at index 4. This is at index 7. So they should also reach to the same indexes again. But once you merge them together in a temporary array, they will be stored at indexes 0 onwards. So you will get 7, 8, 14, 15 stored at 0 to 3. 7 will be at 0 initially. So they merged together into temporary array here, while copying back your indexes in temporary array are temp 0 to temp this, but here the indexes must be ARR4 to 7. So that's why I said you have to be careful about the indices, especially in the ARR. Never assume that indices are always 0 onwards, always. In recursively, for the right side sublists, indices will not be always 0. But for temp array, they will be guaranteedly 0 onwards. So you have to be always careful. Starting point will not be always 0. Hence, this is what I wanted to tell, that you be careful about this. Having said that, now I think I will stop, and you know what you have to do. You have to do your homework, and your homework is simple. You are all well aware what to do. What you have to do is simply try to implement recursively merge sort using recursive merge sort function. And another function merge. Modular programming will suggest that you should use merge as another function, because merge is again a standard functionality which might be needed and reusable in many places. So any two sublists present in an array can be merged via this function. So use these two and test it well for all data. I have shown last class, in the last video, various types of data. So you must check it for all types of data, which means sorted, reverse sorted, random, and all cases with and without duplicates. Sample data in the last video I have shown, try all that. And further, read and understand concept of stability. How that word sorting or stable sort is relevant, read and understand from the book. And make a clear understanding, because in interviews, you will be likely to be discussed this point, and if you answer it crisply, your selection probability will increase a lot. And that will show how clear you are. Similarly, they will try to understand from you, are you knowing how merge sort is internally working, which step is happening first, which step is happening next. They will show you some data and then ask you explain how this will be actually internally working, how recursion will internally go and reach to the lowest steps. So internally, actually, all sorting is happening via merging only. And that merging is actually be doing everything. that you should be able to understand and develop a visualization how this internal division happen, how recursive call comes next. Like in case of a factorial I explained, same you should be able to visualize for the merge sort. Develop a good understanding. Next class, we are going to discuss another complex or relatively more difficult recursive call, that is quick sort. And that will again use recursion. So recursion concept should be clear and recursion programming should be understood. So we will be reusing the recursion again. So prepare well and you should be understanding the working of merge sort as well as recursion in a good way. Bye-bye. All the best to all of you.